Okay, hello everybody. We might get started. There's still people joining the meeting, I guess, but by the time we get through the introductory and the housekeeping, hopefully most people will have logged in. So yeah, hello and welcome everyone to the fifth quarterly webinar in the Harvest Strategy series. There's going to be 11 more of these, I believe, so a lot more interaction to come in these webinars. The series is being coordinated by the Ocean Foundation as part of their Common Oceans Tuna Fisheries project, which is funded by the Global Environment Facility and implemented by the FAO. So the previous webinars have explored topics, particularly around harvest strategies and how they're being applied in the various tuna RFMOs and various other challenges specifically related to tuna fisheries. So my name is Paul Hamer. I work for the Pacific Community, or SPC, in the Oceanic Fisheries Program based in Namibia, where I oversee work on tuna assessments and harvest strategy development for tuna in the Western and Central Pacific Ocean. So today's webinar will delve into some of the many challenges of managing fisheries in the face of climate variability and climate-driven changes in fish population dynamics, biology, and distributions. We'll have a focus on tuna fisheries, of course, as the theme of these webinars, but we'll also be hearing about experiences and examples from other fisheries. And we'll explore how management procedures can be developed using MSE to take account of these potential future changes and uncertainties, and hopefully provide RFMOs with a level of confidence that a chosen management procedure can perform effectively into an uncertain future. We're really privileged to have 5 incredibly eminent speakers for this webinar tonight to enlighten us and to promote thought and discussion on this important topic. So I really look forward to the presentations and please ask questions at the end of the talks and let's have a good discussion at the end. Just before we get going, just some housekeeping. So we have around 2 hours for tonight's webinar. The first hour and a half will be devoted to the presentations, each of which will be around 15 minutes long. After the presentations, we'll have a 30 minutes Q&A panel session. Please turn your cameras off and mute yourself unless you're speaking. And please be aware that we have interpretation in English, Spanish, and French. And so to enable the interpretation to your language of choice, select the interpretation tab at the bottom of your Zoom window. So we'll generally hold all questions until the panel session, unless the speakers finish very early and there's some burning questions. To engage in a question or a comment, please use the raise hand function, so I'll keep an eye out on that. Alternatively, I think you may be able to post questions in the chat box and we can pick those up as well. And finally, we'll be recording today's session and it will be available and posted to you on the YouTube channel. So without further ado, I'd like to introduce our first speaker, Dr. Callie Chris. Callie is Deputy Assistant Secretary for International Fisheries at NOAA. She has extensive experience in public sector, academic, non-profit and legislative aspects of environmental and fisheries policy. Callie's role with NOAA addresses complex challenges associated with international fisheries, from food and economic security to the sustainability of shared marine resources and the impacts of climate change. She has academic qualifications in earth sciences, marine science, and oceanography. So Callie will kick us off with a look at how the various tuna RFMOs are bringing climate change into their discussions and decision-making. So we're going to start at the high end of the town and work into the science as we move through the session. So thanks, Callie. I'll hand over to you to take it away.
Thank you so much, Paul. Thanks to the organizers for inviting the United States and NOAA to represent. And thank you to everyone who's here from across all of the time zones. and thanks, Paul, for the introduction. I'll just add that my interest in climate change is deep. I'm a climate scientist, and so this specific topic is very near and dear to me, as in the work that I'm currently undertaking in the international fisheries space. Thanks, Shana, for sharing your screen. And if we could move to the next slide, please. I've been tasked with providing a high-level overview of climate change and the fisheries issues. And so this is just a high-level image to get us thinking about climate change and its impacts on fisheries. And it's in an embedded figure. And if you start in the middle, you can think about all of the impacts, including temperature change, extreme events, sea level rise, ocean acidification. I would add deoxygenation and some of the large-scale changes in ocean circulation to those listed here as issues that are likely to have an impact on fisheries issues. And those are detailed in the next outer ring here of things that include shifting distributions and changing productivity. And then I think what's key is here is how we approach the changes in the ocean system through fisheries climate ready management, which would be starting at the top of that circle with detecting those changes and moving clockwise around, understanding the mechanisms of change that are detailed a little in the inner circle, evaluating the risks and priorities, and this I think will come in some of the in the discussion that's coming, assessing and forecasting, and then communicating. And I would also add enabling really decision making at the RFMO level. And I apologize for using an acronym. I'm just so that's regional fisheries management organizations, and I will probably use that a great deal going forward. If we could have the next slide, please. This is an overview at a high level of the 5 big tuna RFMOs and the issues and the ways in which each one of these organizations is taking climate change into account in its decision making and in its scientific processes. I'll be starting in the order of, I believe, WCPFC first, the Western and Central Pacific Fisheries Commission, followed by ICAT, the International Commission for the Conservation of Atlantic Tunas, because that's work that I'm directly involved with as the U.S. Commissioner to both of those organizations. We'll also include a bit of a discussion on IATTC here and IOTC, as well as the CCSBT. So next slide, please. Again, starting with WCPFC, and next slide. Okay, this is a timeline of the work, and WCPFC was out in front of this pretty early in 2019 when they first adopted a resolution on climate change calling for the consideration of climate change impacts and supporting research. This was followed by action in 2022, where WCPFC considered how to really operationalize that original resolution that including climate change as a standing agenda item in future meetings. And just last year at the annual meeting, WCPFC tasked the United States and the Republic of the Marshall Islands as co-leads to develop a work plan to address climate change impacts on WCPFC fisheries in the convention area. That includes a scope and feasibility study of conducting a climate risk assessment of all active conservation and management measures. And I want to spend just a moment here. The work plan concept is something that I think you'll see as a common theme across most of the tuna RFMOs at this point. But the idea of conducting a risk assessment associated with climate risks on all of the active CMM, the CMMs at WCPFC is pretty innovative. And the only This is the only tuna RFMO that I'm aware of at this time that is considering that. And so should it move forward at the annual meeting this year, um, uh, the idea is to identify where in the active CMMs there's a climate risk. And then when those measures get open, that provides a resource or a tool for the managers to identify opportunities to modify those CMMs to address that climate risk. It wouldn't be mandatory, but it's certainly a new tool in the toolkit here. I'd also like to start off here in saying, because this is a common theme, that the value of management strategy evaluations and harvest strategies is a common theme that is appearing in all of the work plans that the RFMOs are identifying as a tool to address the risks of climate change through that process, and a way to potentially provide more information to decision makers as they're making those decisions on final harvest strategies that can address the risk of climate change at the outset through that process. And so the work plan for WCPFC is specifically notes the value of that, and you'll see that throughout as we go through this talk. Okay, next slide, please. Moving to ICAT, and again, next slide, we'll see the timeline happening there. In 2022, ICAT took its first action on climate change by adopting the resolution 2213. I'll note that all of this is publicly available. So if you want to look at the specifics of any of the resolutions or measures that have been passed, this is all available on each of the RFMO websites. In 2022, what ICAT did was establish a joint experts group on climate change to start talking about how the commission jointly between the science body and the commission body, the managers, could jointly identify a potential plan of action for addressing the risks associated with climate change on the fisheries that ICAT is responsible for. And so that first meeting happened in 2023, and started charting the course for the work ahead at ICAT. And I'd like to note that Dr. Chung, who's also a speaker here, participated in that first meeting of the joint experts group, and to set the stage really for the issue as fisheries managers are starting to really consider the impacts of climate change. The next action that ICAT took, again at the annual meeting in 2023, was to adopt another resolution to continue the work of the joint experts group in 2024. We just convened that meeting a couple weeks ago and continued the discussion on the plan of action, which again featured the value of harvest strategies and management strategy evaluation as a tool in helping managers make decisions that are climate informed. ICAT undertook a stock take exercise as well across all of its subsidiary bodies and working groups to identify where climate change is being discussed in the organization, and also identify gaps, work that could be improved, ways of improving the communication structure across the bodies. So lots of work happening there. And at the annual meeting, the goal would be to adopt a plan of action for the work ahead. Moving forward in the next slide, please, I believe we'll look at IATTC. And I will, in full transparency, acknowledge that I don't work at IATTC, so I will be giving an overview of what's available. But IATTC has undertaken a great deal of work. And if we could move to the next slide, please. Starting in 2023, IATTC, the Science Advisory Committee, added climate change as a standing annual agenda item, and they hired a full-time staff scientist to work on climate change impacts. So wanted to celebrate that effort. And they also, just this year, proposed a 5-phase climate change work plan that's very detailed, I believe on the order of 27 pages. aim to promote climate resilient fisheries in the Eastern Pacific Ocean. So wanted to acknowledge that work. And moving next, I believe, to IOTC. If we could go to the timeline slide next. Thank you. In 2022, similarly, the timelines on this are all pretty similar as momentum was gathering. You can see that IOTC adopted a resolution on climate change and focusing on the scientific committee, considering climate change and providing advice to the commission on those implications. In 2024, IOTC amended that resolution to provide capacity building to facilitate better understanding of the climate change issues, assess the impacts, again, set climate change as a standing agenda item, which has been a very popular issue, and encouraging the sharing of climate change information. And I was remiss in saying, in the IATTC space, again, harvest strategies and the value of management strategy evaluation in assessing the risk of climate change is also featured heavily in the IATTC work plan there. So would encourage you to take a look at that. Heading to the next slide, CCSBT, and again, if we could move to the timeline, please. There has been a report of the Extended Science Committee highlights on the impacts of climate change on the range of southern bluefin tuna. And while there isn't a specific climate change resolution, there has been a great deal of focus on the need for management procedures to be robust to the likely or plausible levels of non-stationarity associated with climate change. So let's go to the next slide, please. Okay, I just want to acknowledge that while we're focused on tuna RFMOs here, there's been a great deal of momentum across many RFMOs that include, and I wanted to acknowledge CAMLR because they were thinking about this in 2009, so really very much ahead of many of the other fisheries bodies. NPFC, the North Pacific Fisheries Commission, addressed this in 2022, followed by SPRFMO in 2023. The Central Arctic Ocean Fisheries Agreement in 2023 also adopted a resolution on climate change, as did NEAFC, and in 2024, CIOFA. And IPHC also did, and for those of you who don't know IPHC, it's the International Pacific Halibut Commission. It's a small bilateral organization between Canada and the United States. But I think it's really impressive that we're at a point where we're acknowledging the impacts of climate change on the way that we manage fisheries internationally, and looking at ways to operationalize the work ahead. So moving to the next slide, please. I think I've now said this. There's a great deal of momentum to adapt international fisheries to climate change. And so wanted to emphasize just one last time here that effective harvest strategies that are informed by management strategy evaluations, which incorporate climate risks, are a strong tool to inform management decisions. And they're a tool that, in my role, co-chairing a few of these conversations, comes up consistently as something that we need to lean on for work plans and addressing the risks of climate change going forward. I think the one point that I would add here is that it's important that we're discussing climate change, but as we're looking at operationalizing, I think one of the key components that we need to think about is not just how we're addressing it within the scientific context of the RFMOs, but how we're translating that advice into decisions that the managers are making. And so with that, you can read the rest of the slide, but I think this is my last slide, but if we can move to the last one. And just say thank you so much. And I look forward to the conversation ahead and the questions. And thanks again to the organizers for, thanks again to the organizers for including me in this conversation. Thanks.
Great. Thanks, Callie, for setting us up well. And yes, it definitely feels like there's a lot of urgency around bringing the climate change discussions into these large RFMO groups and meetings, and particularly take note of your mention of the word translating at the end there. There's a lot of technical terminologies and technical science involved in climate change and fisheries, and I think what we've learned at SPC with our work is that you know, we need to be out there also from the technical aspects and explaining the climate language and getting that well understood amongst the decision makers in these RFMOs. So thank you very much, and we'll look forward to hearing from you again later in the panel session. So let's move on to our next speaker, Dr. Patrick Lahody. Now, Patrick wears two hats. He's working both for Mercator Ocean International in Toulouse, France, and for the Fisheries Program of the Pacific Community, or SPC. So he's one of my colleagues, and I'm forever pestering Patrick with emails lately, trying to understand oceanography and climate impacts on skipjack tuna. So thanks, Patrick, for all your emails and responses. But he's had a long history working in the Pacific for SPC, looking at oceanography, climate, and pelagic fisheries. And he's been a really key contributor to the development of spatial numerical models integrating knowledge of microneptile, prey organisms of large marine species, and large oceanic predators, tuna biology and ecology, and most notable is his work on the Sepidum model, I guess. He's a world expert on climate implications for tuna dynamics and has made an immense contribution to our knowledge of tuna in the Pacific. So thank you, Patrick. Patrick's talk, Shifting Distributions of Tuna in the Pacific. So over to you, Patrick.
Thank you. Do you see my screen? Good.
Yes, yeah, you're on slideshows, so it's all good. Thanks.
Okay, thank you, Paul, for this nice introduction. So I'm going to give a brief overview of the work we are doing to understand the change in distribution of tuna in the Pacific. And that's include the development and the use of model that combine the impact of climate, natural variability, and the effect of fishing mortality on tuna stocks. To introduce the topic, a very brief introduction on the tuna fisheries. So it's, as you know, it's a world major industry. There are tuna fisheries in the three oceans between 50 north, 50 south. And briefly, we can distinguish between the surface fisheries with pollen line, but mainly now percent fisheries. So you have the map on the top with the distribution of the catch. And that's where the most of the global tuna catch is coming from, and it's mainly for the tuna canoes. While the other major fishery is the longline fishery, targeting individual fish in subsurface, and for the sashimi market or fresh market. In terms of catch, you see the evolution of the catch on these plots on the left. So the Western Central Pacific Ocean provide about half of the global tuna catch. And within this catch, it's the skipjack species that is the most exploited and used species. Sorry. And so this has been shown already, but we have in the Pacific, we have two different organizations. So the WCPFC for the Western Central Pacific Ocean and the ITTC for the Eastern Pacific Ocean to manage these stocks. So most of the global tuna catch is due to the species that I present here. They share, of course, many common features since they belong to the same taxonomic group. But there are also differences with a gradient of affinities between the warm tropical and cool temperate oceanic regions. And this gradient is reflected in key population parameters of the species in terms of growth, longevity, age at maturity, and natural mortality. So these species occupy different ecological niche in the ocean, which are reflected by different thermal preferences or tolerance to oxygen concentration for these different species. Given the sensitivity of the species to oceanographic, I will show here a typical behavior of two species, so big eye and skipjack, showing the different niche they occupy. Here you see two tracks, individual tracks recorded by electronic tags that have been implemented on this fish. And you see typically on the right, the skipjack fish moving and staying in the surface layer, the first 100 meters of the ocean. While for the big eye, we have very different patterns with regular dives, allowing this species to dive below 300 meters to catch mesopelagic fish that you can detect from acoustic systems. And so with very different ecological environment in terms of temperature and oxygen concentration particularly. So given the sensitivity of the species to the oceanographic variables, it's not surprising to see, to observe that a strong climate signal like the El Nino southern oscillation. So I guess you are familiar with now with this El Nino, La Nina phenomenons that are coming regularly in the news. And this we have shown many years ago that this fluctuation between the two phases of ENSO, El Nino and La Nina, generate a strong shift, spatial shift in the skipjack stock, which concentrate in the Western Pacific, in the warm waters of the Western Pacific during La Nina, and extend in the Central and Eastern Pacific during El Nino. So the fisheries, so the catch, the black circle represent the catch that is superimposed on the sea surface temperature here, show that the fisheries follow of course the change in the distribution of the tuna, and this corresponds to effectively a movement of fish as shown by experiments with tagging data. And this change in distribution has a strong impact on the economical revenue and the fishing in the EEZ of the Pacific Island countries that you see on this map, with a big fluctuation in the EEZ catch, whether if you are in the eastern or western part of this region. And the Pacific Island countries now have signed an agreement to manage, to account for this ENSO fluctuation in the management of the allocation of fishing effort in the area, allowing to smooth the economical, the impact of ENSO in the economical revenue of the fisheries. Natural climate variability can also influence the abundance of the stock, not only the change in distribution, and this is through the mechanisms of recruitment. So typically the change in the ocean productivity has an impact on the prey of fish larvae, and can induce more or less mortality on the early life stages, and that create a fluctuation in the abundance of the stock. Unfortunately, we do not have a lot of direct observation of these effects, but here I show quite an interesting sequence of events that occur at the end of starting at the end of the El Nino event in 97, 98. We observed a large bloom of phytoplankton, So the first level of the food chain in the ocean. So here with the yellow spot here. So during few months and a few months later, the fishery were concentrated in the same area, and we observed in the size frequency of the catch, so the fish that are measured on board, very unusual peaks of small size fish that correspond to the peak in the recruitment of small fish in the stock. So that's this sequence of events give some confidence that the change in primary productivity control also the abundance of the stock. Okay, so now how we can integrate all these mechanisms and try to see if we can forecast some change in the stock based on that variability. For that, we need a model. So as Paul said, we developed for many years now a model called CPODIM, a spatial ecosystem and population dynamic model. So the idea is to combine the classical equation of population dynamics for given fish species, and the link to the key environmental variables, drivers of the habitat of the species. So on one side, we have a standard definition of population by age, so by cohort of fish. And on the other side, we define two key habitats, so the feeding habitat and the spawning habitat. So the feeding habitat is a combination of preference of condition for a given species to access the maximum of prey. So as I shown before, it can be in surface or in subsurface. So the conditions are quite different, and the preference of the species also are different. And we have also the spawning habitat, which control the recruitment in the population based on the preferred temperature for spawning, the presence of prey for the larvae, so the zooplankton, or the predators. So the myconecton is feeding on the larvae of tuna. And the model is spatial. And so we have a passive drift of larvae with the currents, but passive and active movement of the larger fish, because we know that they are swimming. And so along the gradient of habitat that we define, so the fish will swim to access the best feeding or spawning areas. So to run this model, we need temperature, oxygen, dissolved oxygen in the ocean, primary pollution, and the currents. And of course, we need also to introduce the fishing. So we know the fishing effort and the catch, so we can define different fleets, so the percent, the long line, and predict the catch in the model based on the observed fishing effort. And comparing the predicted and observed catch, we can estimate the best set of parameters of the model that give us the reference model for a given species. So typically, we apply this model to reconstruct the past history of a species and the associated fisheries. And we estimate the model parameters based on all the data we have, so catch, but also, we have also tagging data and size frequencies. And then we validate, we verify that the model is robust. So by checking that the prediction are still good outside of the time window we use for the estimation, for the optimization, but also by comparison with other models. So for example, the model used by the WCPFC in the Pacific. We verify that the model also predict well the natural climate variability that we have observed. So you have an example of El Niño, La Niña, El Niño situation for the skipjack here. And finally, we can also test if the parameterization that has been achieved in one ocean, for example, the Pacific, is also valid in the other oceans where we have the same species and the same kind of fisheries. So when we are confident in this model, it's possible to project the future of the population, tuna population, using the same environmental variables, temperature, primary pollution, and so on, predicted from Earth climate models based on IPCC scenarios. So there are different scenarios, and we use different models to account for the uncertainty of the projection. But because, of course, for this long-term projection, we have quite many sources of uncertainties, both for the physical model and the biochemical models that predict the primary production or the oxygen. The result is mostly a decrease in the Western Central Pacific Ocean, especially for skipjack. So here you see the difference between the historical period and the projection for the mid-century for larvae on the left and the total biomass of skipjack on the right. So you see we have a decrease in the west, in the west, yes, and an increase in the east. So globally, we made the first analysis for three species. And according to the scenario we use, of course, the results are a bit different. And the impact, of course, on the Pacific Island countries also different. So if we can stay below, at the level of the threshold that has been agreed at the Paris Agreement, we should see a minimal change due to the climate change at the scale of the Western Central Pacific Ocean, and the change should be expected mostly between the EEZ of the Pacific Island in the west or in the Central Pacific. So still with a strong impact of ENSO in the annual catch of these countries. If we move to intermediate scenarios of greenhouse gas release, here we start to see a loss in terms of average annual economical revenue for the Pacific Islands that we estimate for the moment at $12 billion per year, assuming that the loss is correlated to the change in biomass, which should be in average of 3.4% in that case. And if we consider a very high emission scenario, in that case, the loss should be much higher, so estimated to 90 million in average. So to conclude, now we are in the phase of a second analysis with a new ensemble of climate model projection that is coming from the very last IPCC climate models. So we are going to revise the historical reference model first with new data, improved resolutions. We are moving from 2 to 1 degree. And also we will test the model that we obtain in the Pacific, in the Indian and Atlantic Ocean. And I think it's important, we need to develop tools to project also the fishing impact, because of course the climate change is not the only driver of the future of the tuna stocks. And we are, of course, working on the next version. We should see more better improvement in the physical biochemical model, but and also higher resolution and maybe decadal forecasts, so with more accurate short-term forecasts rather than long-term century projection. And I will stop here. Thank you.
Beautiful, thanks, Patrick. Always learn something new when I listen to your presentations on the SEPADIM modeling. I was actually looking at plots from SEPADIM just before this meeting, as you'd probably expect. It's a great work, and it's a long-term piece of work that's been going for many years, and now it's sort of moving to a new level of trying to get resolution increases in the modeling. And I think one of the things you touched on is that, and we've spoken about, is that the data sets that you guys need to do this are not good enough. And particularly in that warm pool area, there's a lot of limitations in the information, and the observations we have there on things like primary and secondary production to validate these models is severely lacking. So it's an area that we need to try and work on getting more done. And I think we're going to hear later on how these kind of modeling approaches can be really valuable for MSE because they provide us with some of these insights into what the future might be like for these fisheries that we can then incorporate into operating models and uncertainties in MSE. So I think some of the latter talks are going to get more into that. So thank you, Patrick, and we'll look forward to hearing you from you again later. Thanks for your presentation. Okay, let's move on to the third presentation. This is from Dr. William Chung. William is a professor and director of the Institute for Oceans and Fisheries at the University of British Columbia. He's the principal investigator of the Changing Ocean Research Unit at UBC. He's also the Canada Research Chair in Ocean Sustainability and Global Change. And his work addresses policy relevant research questions that cut across multiple disciplines, from oceanography to ecology, economics, social science, and range from local to global scales. So I look forward to William's talk now on the effects of climate change on tuna fisheries. So thanks, William. I'll hand over to you.
Thank you so much, Paul, and thank you so much for inviting me to join this meeting. In this talk, I will build on the wonderful talk that Patrick has given on the climate change effects on tuna distributions, on tuna abundance, and its effects, implications for fisheries, but then highlighting some of the overarching issues that are more relevant to tuna and as well as other pelagic fisheries and its implication for their management. I will be drawing primarily from some of the research that we have, myself and my group have taken in the last few years, but I'm not comprehensively covering the literature. There are things from the literature that would are relevant to those points, but I just wouldn't be able to mention that in my talk. So please excuse me if you know of some other better examples to illustrate the points, and would be happy to discuss that in the later discussion section. Just to reflect on Kelly's point about how climate change would be affecting the fisheries, changes in the ocean conditions, such as temperature and other ocean conditions, affects the biology of the organisms, affects population dynamics, as Patrick has really nicely illustrated, such as growth, abundance, and distributions. This would then affect the assemblage, community structure, and then affects and impacts fisheries through changes in species compositions of catch, economics or potential maximum catches, and the economics of fishing. And ultimately, it interact with some broader human societal issues, such as food supply, the price of energy, as well as other broader climate mitigations and adaptation concerns. Although managing fisheries is really specific to the fish stocks, but then to deal with climate change, there's actually also the needs to look broader at these interconnections between from the oceanographic size to the human dimensions, to the economics at different levels and scales. And the effects of climate change has already been affecting the oceans and fisheries. In fact, intensifying climate change is already shown to be increasingly and adversely impacting many fish stocks and their fisheries. This is drawn from the key findings of the recent cycle of Intergovernmental Panel on Climate Change Assessments, both on the Special Report on the Oceans as well as on the Sixth Assessment Working Group 2 report. It shows that there are already robust evidence that globally the species are shifting their distribution range, changing in the timing of their biological events, and that leads to changes in pelagic ecosystems and has mostly negative impacts on many fisheries. And some of the specific impacts on regional fisheries are also highlighted. These are examples that I draw from the input report. There are also medium to high level of evidence that shows that there are already impacts on pelagic ecosystems in the North Atlantic, in tropical Atlantic, in South Pacific. Although the evidence for fisheries is more varying. I mean, there are lots of evidence in the North Atlantic, but a little bit low evidence because of the less amount of relatively less amount of research in the South Pacific on the topic. Not that the evidence or the impact is not there. It's more reflecting the amount of research that are being done there. So the key message is that we are already experiencing climate change effects on marine ecosystem, the pelagic ecosystems that are important to tuna as well as their fisheries. And I'm going to summarize some of the one of the key impacts on the tuna and pelagic fisheries, and draw out some of the key concerns that I feel are important to think about in managing the tuna as well as pelagic fisheries. Some of it is already highlighted by Patrick in his talk. So with changing ocean conditions and particularly warming, deoxygenations, and other changes that Kelly has mentioned, we are expecting shift in species distributions so that they can find refuges or habitats that would be suitable for them to live, and particularly for species like tuna, where they are highly mobile, the rate of shift in distribution is fairly high. But in doing so, it would affect abundance, and in some cases, it would decrease in abundance, as Patrick has highlighted, or it would actually, in some when changes are strong, it will lead to what we call local loss or local extinction. So it actually disappears from a local regions because the environment becomes not suitable for them to live. And such shift in distributions will bring in new interactions with other species. And particularly relevant to fisheries is that when managing fisheries, one of the concern is about bycatch, particularly on species that are of conservation concern, sharks, sea turtles, seabirds. And so such shift in distributions will bring in new interactions with these non-target species, and also bring challenge to their the management of their bycatch. At the same time, shift in distributions can also affect the distributions of the fish stocks across political boundary. And fish doesn't need visas to cross political boundary. They can travel as they want if they can. So this brings in the challenge to transboundary fisheries management. And also, such shift in distributions will also bring in new interactions or intensified interactions with some other human activities. And so in my talk, I will highlight example or to illustrate how these changes would challenge harvest strategies, bycatch management, transboundary fisheries, and interaction with other human activities. So let's talk about the first things, which is the implications for harvest strategies as the fish shift their distributions and abundance. I'm drawing examples from a recently completed studies that we use computer simulation modeling tools to explore the changes in distributions of fish stocks and how that affects the harvest strategies. So in our simulations, we look at fish stocks and how they performed under different climate scenarios. And what we find is that in many cases, when climate change or greenhouse gas concentrations increase and thus global warming level increase, the biomass of many of these fish stocks actually would decline. And so the map shows the sensitivities of those fish stocks to climate change. It can be represented by the slope of this curve, this line. So the higher the slope, meaning that there would be a bigger decline in biomass relative to each degree of warming, and meaning that the increasing intensity of climate change. And a lot of the highly sensitive fish stocks are concentrated along the tropical oceans, particularly, for example, the tropical Pacific Oceans. But what it means is that with the effectiveness of achieving the particular biomass targets will also decrease under climate change. For example, with weak carbon mitigations and high level of global warming, biomass of sensitive stocks and regions are projected to be lower than the current overexploited level or current level. And therefore, more conservation-focused rebuilding plan or more conservation-focused harvest strategies, in addition to climate mitigations, is needed to achieve biomass targets, at least even keeping at the current biomass level under climate change. For example, to achieve at the same biomass level of today under climate change, it requires less fishing to achieve the current biomass level. A large part of the tropical ocean is projected to be below the current biomass level under harvest strategies of, for example, F equals F 0.75 and a global warming level of 1.5 degrees Celsius relative to pre-industrial level. And if countries only implement their existing climate policies, the world is expected to see a warming of around 3.2 degrees Celsius by the end of the century. And this means that even a fishing mortality rate at around 0.75 of the maximum sustainable yield level to maintain, it won't be able to maintain the current biomass level. It needs to be substantially reduced. This also means that they will intensify the trade-off between achieving biomass targets and fisheries. So there will be less fishing that is possible in order to achieve biomass targets for specific harvest strategies. And that for some of the fisheries, it means that there will be less catch, less revenues, and less potential supply to food. Okay, so besides the effects on the harvest strategies, it also affects bycatch management. I'm drawing an example that in the Atlantic, particularly in the ICAT regions, where we modeled the distributions of tuna fish stocks using species distribution modeling tools. So we use multiple modeling tools to see how the habitat of tuna would change under changing ocean conditions, like temperature, oxygen, salinity, and things like that. Basically, we projected a overall decline in habitat suitability in many of the species in the Atlantic Oceans. But then for some individual species, it actually has shifted distributions. For example, the skipjack tuna or albacore tunas, they're shifting their distribution forward with increase in habitat suitability in northern part of the range, but then decrease in the tropical part of their range. We also modeled the bycatch species, tuna, dolphins, sea turtles, or billfish or other shark species. And in general, what we find is that, and we calculate the potential overlap between bycatch and the target tuna species. And we find that on average, the habitat is projected to increase in the ICAT regions. And so it means that it's based on the projections, it is by under the high emission scenario by mid-century, so a few decades later, the climate change will continues to intensify the potential interactions between bycatch species and the target species, meaning that there needs to be some thinking about how to manage that potential increase in interaction between these species. The third things I want to highlight is the challenge to transboundary fisheries management. Transboundary species, tuna, and other migratory species are really important contributions to global catch and revenue. There are also transboundary species between countries as well. For example, the halibut is an example that Kelly highlighted. And we modeled the distributions of these transboundary species under climate change scenarios, looking at how the proportion of changes between different political jurisdictions would change over time. And then we use that as metrics to assess how much it would challenge transboundary fisheries management. When one fish stock shifting more to another jurisdictions, it means that there will be more challenge to those transboundary management. And what we find, this is a map that shows the direction of shift of these transboundary fish stocks between exclusive economic zones. We show that there will be substantial changes in the stock distributions of these transboundary fish stock between the exclusive economic zones, even in the next decades or so. A good example is Atlantic mackerel dispute in the North Atlantic that I think all of you are aware of. And that also highlights the point that with this shift in fish stocks, transboundary fish stocks, it can challenge transboundary fisheries management if it is not prepared, and that it can, some of it can actually increase the risk of conflicts or dispute between jurisdictions managing the transboundary fish stocks. So it also means that we need to be prepared so that we don't get caught unexpected, and that can then reduce the risk of these potential conflicts and disputes associated with transboundary fisheries management changes under climate change. And not only between UEZ, we also, in a recent study that is not published yet, is under review, we look at the shift in fish stocks between EZ and high sea, particularly the RFMOs, and we find that there are substantial changes between EZ, transboundary fish stocks between EZ and RFMO, and between RFMO as well. So the message is similar for both between EZ as well as for transboundary fish stocks between EZ and RFMO and between RFMO. The final point that I want to make is about the interactions with other human activities. And this is a recent study done by one of my postdocs, or contributed by one of my postdocs, and led by Almond. It basically highlights that an example of potential interactions between deep sea mining and the potential impacts of deep sea minings on the pelagic ecosystems and the pelagic fisheries, such as tuna fisheries. And this projection used Patrick's models, Sibaden, and that shows that with climate change, the biomass of the tuna fish stocks will increase its overlap with locations where deep sea minings are planning to happen in the Atlantic Oceans. And this is just an example, very specific example, but it illustrates the bigger points that fisheries management need also look at the broader interactions between other human activities, that it is affecting the border interactions between the natural and human systems, and that fisheries management also need to broaden the scope, not just focusing on managing the fish stocks, the fisheries, their abundance, but then also looking into how it's potentially interacting with these potential other human activities that may both affect the fisheries as well as affecting the people who are depending on these fisheries. So overall, this is the summary. Climate change is going to intensifying already the impacts on fish stocks and fisheries, and it is intensifying climate change is expected to reduce overall biomass of some of the target species, and that affects harvest strategies, potentially requiring a much more conservation-focused harvesting strategies. But that also increase the trade-off between achieving the biomass targets, conservation targets, and other objective of fisheries for economics, for biomass protections. Climate change is also potentially increasing the risk of conflicts and disputes through challenging transboundary fisheries management. It can also increase the interactions between the tuna and pelagic fisheries with bycatch, and thus there's a need to think about how those intensifying interactions needs to be managed. And it needs also to ultimately think broadly about how to integrate across multiple challenges for managing fisheries, about how to manage climate change through adaptation and mitigations, and its implications for biodiversity conservations and food securities, and exploring potential solutions to address these multiple interacting challenges. With that, thank you very much.
Great, thank you, William. That was a really nice follow-on from Patrick's talk, and really getting us to think about maybe some of the things we haven't thought about in terms of the implications of changes in fish stock distributions and productivity, and how they might interact with things like seabed mining and other uses, which I hadn't really thought about too much. That you know, movement of fish stocks and expansion into areas, maybe fleets struggle to go with them in certain cases, but definitely the transboundary EZ issues are probably high on people's radars, but developing management that's going to be able to deal with that is something that we're sort of facing. So thank you so much for your presentation. We're going to move on now to our next speaker, Dr. Desiree Tomasi, who is a scientist at the University of California and the NOAA Southwest Fisheries Center in La Jolla. I will point out that Desiree is actually on holidays at the moment, and so is Patrick, and so is our next speaker, Ava. So we really appreciate the dedication of you three for joining us tonight while you're on leave. Desiree has been referred to as a pioneer in the field of fish forecasting. I read that somewhere. Her research aims to understand the effects of climate change and climate variability in marine ecosystems, and to apply this understanding in support of fisheries management decisions. She's working on management strategy evaluation, MSE, for albacore tuna to quantitatively evaluate the utility of environmental information, including seasonal to multi-annual climate forecast, to help identify climate robust management procedures and benchmarks. So thank you, Desiree. I'll hand over to you for your presentation.
Thank you, Paul, and hi everyone. I'm going to share my screen. Thanks also to the organizers for inviting me. So you should be able to see my presentation. So hello everyone, and happy to be here to talk about management strategy evaluation and climate change. So as we've heard from the presentation of Patrick and William, we know that climate is changing, and that is going to impact marine species and fisheries that we care about. And so we've heard from Patrick that's going to impact shifts in tuna distribution and tuna abundance, and that's going to lead to changes also in landings. And here I'm illustrating some example that I worked on from the US West Coast in the California Current, where I've been doing a lot of my work. And so the question that many managers in our region and stakeholders are interested in is, are our current management system robust to such impacts? And so are our management system climate ready? Are we going to be able to still adequately meet our management objectives given these projected impacts? And some of the questions that are of interest are, will scientific surveys still cover, the main habitat of the species, the target species? And will that data be as accurate under climate change? And that's also, both scientific survey data, but also fisheries dependent data. And then something that William just touched upon right now in terms of transboundary issue, given shifts in distribution, will availability change across management boundary? And can we expect new transboundary issues to arise? And then questions related to stock assessment. Will stock assessment performance be maintained under climate change? And then that can all be wrapped up in catch advice. So will current management strategy remain effective under climate change, or perhaps alternative rule might perform better? And when we think about effectiveness, we are thinking about effectiveness relative to some specific management objectives. And often those are around the target species and the fishing communities that are dependent on that, but they might also involve protected species that are dependent on the target species of interest and as food, or maybe in terms of bycatch issues. And so given those objectives, are there actions that we can take to mitigate adverse impacts, or perhaps to capitalize on any positive impacts? And today I'm going to show you how we can use management strategy evaluation as a great tool to test the robustness of management systems to climate change. And so management strategy evaluation, or MSE for short, is a process that evaluates the trade-offs and the performance of a set of candidate management strategies under a range of uncertainty using computer simulation. So it's already developed to test the robustness of candidate management strategies. And if you're interested in testing robustness under climate change, then in those uncertainties or what-if scenarios that we are testing, we can include climate-driven uncertainty. And indeed, a recent paper by Walters et al. Stated that MSE can simulate potential but uncertain effects of climate change on the biological and fisheries system. And so it's a great tool to test robustness of harvest strategy to climate change. So here below, I have a schematic of what an MSE is or how it's built. And so we have here in the middle an operating model. So this is a computer simulation of the fisheries as well as the population of interest. And then, so that's our representing the true dynamics of the system. And from that, we are collecting data as we would normally do in the real world. And that data is fed into a management strategy. So here, when I talk about management strategy, you can think of that as a harvest strategy or a management procedure. And it includes sort of all components of management, from data collection to then entering that data into an estimation of stock status, which could be empirical, so just based on data, or it could be done via a stock assessment model, for example, and then that information then goes into a harvest control rule, and then harvest controls are implemented back into the operating models, and the fisheries catch is going to be affected, and then in turn, the population of interest. And so we know climate, as we've heard from the previous presentations, can affect many parameters that are part of our operating models, like productivity parameters such as growth, recruitment, fecundity, natural mortality. And as we've heard, it can also affect catchability. And so how do we integrate climate uncertainty into MSE? One way is to define future state of nature by generating a range of these operating models that include some climate scenarios. So here below is another schematic that is taken from Sipo et al. Paper, which was focused on forage fish, but I think it's a good schematic for explaining MSE in general. And so again, we have here in the blue box the operating model, and in the green, the management strategy. We collect data from simulate data from the operating model, and then that goes into the harvest rule, either empirically or through a stock assessment, and then management is fed back into the operating model. And so one of the key steps in MSE at the start of an MSE process is to identify what the critical sources of uncertainty are, and then construct operating models. So we don't really know what the true dynamics are. And so we construct many operating models to consider all sorts of possibilities in terms of fisheries or population dynamics. And so we construct operating models that can actually consider that model uncertainty that has been identified. And so with climate, we can sit down together with Patrick and William and fisheries scientists and come up with potential future scenario for KOM parameters. So we can ask Patrick, how do you think recruitment of skipjack tuna is going to change, or catchability or growth? And then we can develop some scenarios. But the actual, so the technical detail of how that is done will depend on our understanding of the climate and the biology and fisheries relationship, as well as the availability of oceanographic projections. And so if there is not a clear understanding of those relationships, and if perhaps there are no projections that have been carried out, then one can at least use an empirical approach. And so you consult experts and stakeholders to define potential scenarios. For instance, maybe we do expect an adverse impact on productivity for a specific species, and so we model drop in recruitment. We might not know what exact drivers in terms of oceanographic projections are going to cause the drop in recruitment, but in our operating model, we can model a drop in recruitment scenario. An alternative approach, for instance, we have the CPODIM model, and we can use it to define some projections of recruitment. So that would be a mechanistic approach. So we use existing mechanistic models or even empirical relationship linking climate to fisheries or the population dynamics of a stock. And then those models are driven by Earth system models. And then we have projections of the parameters of interest, such as growth and recruitment. And then those are integrated in a simpler, sort of often single area, single species stock assessment like population model that it's our operating model. And so in this case, there needs to be collaboration between fishery scientists, ecologists, fish biologists, and oceanographers. And then finally, it's again under the mechanistic approach, we could actually use, let's say, CPODIM as an operating model. And so in this case, the climate projection are actually directly linked to our operating model. And Eva will be showing how we can use models of intermediate complexity for ecosystem assessment, MICE, as an operating model that is influenced by climate drivers. All right, so the second part of my presentation, now that you have a general idea of how we can integrate climate uncertainty into management strategy evaluation, I'm gonna exemplify how we can use MSC to test the robustness of management strategy to projected ecosystem change using case studies from a project I'm the lead PI on, which is Future Seas. So Future Seas is a collaborative interdisciplinary effort to explore the impacts of climate change on US West Coast fisheries and to assess what might be the best strategies for managing those impacts. And if you're more interested, the website is at the bottom of this slide. And right now, our focus is largely on what we call coastal pelagic species off of the US West Coast, so forage fish such as sardine and anchovy. And our modeling approach consisted in sort of two steps. So the first step is doing, for instance, what Patrick and William have done, but assess what are the climate-driven changes that we need to prepare for. So assessing what the impacts will be. And we use a suite of impact models, from species distribution model to ecosystem models, that are linked to downscale climate projections. And then we have some impact metrics that we generate in terms of shifts in distribution or shifts in productivity. And the second part of our project is using management strategy evaluation to assess the robustness of our management systems to those projected impacts. And right now, we've done two management strategy evaluation. The sardine one, which you'll hear about, has been completed, and the ecosystem management strategy evaluation that uses the Atlantis ecosystem model is underway. And so I'm gonna start with the Atlantis MSC, which is underway. And so here we are using this ecosystem model to test robustness of forage fish harvest control rules to climate-driven changes. And those climate-driven changes are climate-driven changes in distribution. So we are linking Atlantis to species distribution model output. We also have a MICE model that can produce, generate projections of recruitment that are informed by temperature, oxygen, and advection, and food availability for both sardine and anchovy. So that's also incorporated into Atlantis. And then Atlantis can ingest the downscale projection themselves, and those affect many ecosystem processes that you see listed on the right-hand side of the slide. And so we are also considering changes, climate-driven changing in species interaction, because we are using these ecosystem model as our operating model. And why we decided to use Atlantis was because we were given that the species of interest are forage fish. We were interested in performance metric that also related to predators, so it was important to model predators. But we are also considering alternative harvest strategies that are guild-based, so not single species, or that might be based on the status of the predator, of the prey. And so that's why it was useful to use an ecosystem model for this work. Next is the sardine MSC. So here I don't have the time to go into the details, but I urge you to check out the paper that was recently published. So the sardine MSC was developed to test the robustness of management of sardine under climate-driven recruitment uncertainty. And so we developed different operating models that have different recruitment scenarios, and some of them were driven by regional ocean model output. And here is the list of management strategies that we've tested. And we always compare to a no-catch scenario. And again, you can find the details on the paper. But I think what's important for this presentation is that we don't really know how recruitment is going to change. So we had some what-if scenarios, and some of them were climate-driven. So the no climate was just autocorrelated recruitment, or recruitment that was cyclic. And then we had output from that dynamice model I've talked about, or an empirical relationship between the Pacific decadal oscillation, and we use projection of the PDO and recruitment. And so we generated those different scenarios, and we tested the performance of the harvest strategy that you saw in the previous slide, given some performance metrics and management objectives. And so the conclusions, high-level conclusion that we derived from this sardine MSC was that climate-robust HCR for sardine will be responsive to changes in population status, have a high closure or sort of a B trigger that you can see here at a higher biomass, use assessment estimates rather than survey estimate. Note that this is for sardine, where we actually have a yearly assessment, which is not the case in many other regions. And also we found that it was key to have an interdisciplinary team that worked together, because translating Earth system model output and learning just the jargon of what climate projections versus climate predictions are is important. And learning to translate output from a mechanistic ecological model into, let's say, a single species population dynamics model can also be challenging, because recruitment, for instance, is modeled differently. So that's also why it's important to work together with an interdisciplinary team. All right, so thank you for listening. And I'd like to thank the whole Future Seas team, and especially Robert, Pierre, Isaac, and Barb, who provided some of the material for this presentation. Thank you.
Thank you so much, Desiree. Very interesting presentation, and your last point about the need to bring the biophysical oceanographer models, ecosystem modelers together with the traditional stock assessment scientists, so they can understand what each of them can bring to MSC work. You know, we're clearly relying on people like Patrick and that to tell us, or to give us some insight into what the future might look like. But maybe these more mechanistic and modeling approaches in MSC using multi-species ecosystems are the way to go. And I believe we might hear a little bit more about this from Eva. So our next speaker is Dr. Eva Plagani, the Group Leader for Sustainable Marine Futures at CSIRO, based in Brisbane, Australia. Eva is renowned for her work in the area of stock assessment, ecosystem modelling and management strategy evaluation, and much of her research is focused on climate impacts and adaptation. And she's have a broad range of experience across lots of different species. So we're going to sort of probably move away from tuna a bit in this talk and hear about some other species. So I'll hand over to you, Eva. Thank you so much.
Thank you, Paul, and hello, everybody. Thank you for staying online for the last talk. And I'm sorry if you're disappointed that you won't be hearing a lot about tuna, but I'm hoping to give you some complementary perspectives from some of our work in Northern Australia. So although I won't actually be talking about tuna, there's a lot of the same themes that the other speakers have focused on. Just trying to change. Oh, my slide's not changing. Oh, there we go. So what I'm going to draw on to complement some of what Desiree talked about is some recent examples of a couple of Northern Australian fisheries where we've tried to increase the robustness to climate change, and we've used a range of MSC and changes to harvest strategies to help those fisheries be more climate ready, which is a theme we've heard from all of the other speakers. And so I'm going to give you some examples from Torres Strait in northeastern Australia on the tropical rock lobster, where we also have a multi-species sea cucumber fishery, and then move across to the northern prawn fishery and particularly the red-leg banana prawn sub-fishery. So in Australia, our fisheries are managed by a sort of harvest strategy policy, which is a framework that specifies the predetermined management actions in a fishery necessary to achieve your agreed objectives. So the whole idea of this is that you pre-test the rules that you're going to actually use. And so the notion of a harvest strategy then has particular rules in it. These are the harvest control rules or decision rules that are the rules that tell you how to adjust your TAC or your TAE, for example, from one year to another. But there's other components. How do we check that those harvest control rules perform the way we want? And particularly, how do we check that they perform in a way that is robust to climate change? That's where management strategy evaluation comes in. So we use MSC to simulation test those harvest strategies. The actual management procedures, where that differs a little bit, and we have a mix of different approaches for our different fisheries, and I'm going to give you some examples of all of those in Australia. But the management procedure approach is a more formal specification of all of those components, and then actually simulation testing the robust performance of all of those. So we've heard a little bit from Desiree about management strategy evaluation. I just wanted to share this plot, which is a slightly broader sort of look at how we've used MSC in some of these fisheries. So Desiree talked about the operating model, which is how we simulate the actual underlying reality. We sort of pretend we understand exactly what's going on in a fishery, and this is where we can couple in other components like bioeconomic or social cultural, as well as have climate drivers linked into that. We can link in other ecosystem effects. And we then end up with an operating model or a suite of operating models that we use to simulation test our management models. And we do this in an adaptive feedback process. So that's the whole idea of management strategy evaluation. But the important takeaway here is that it's a very flexible framework that can allow you to couple all kinds of different models, to use ensembles, to use ecosystem models. So Desiree mentioned Cepodium, Atlantis, and then MICE, models of intermediate complexity, which is the approach that my team have mostly been using. One example of that is from our work in Torres Strait, where we coupled together not only the normal sort of biological models, but we also coupled together some social and economic models so that we could evaluate triple bottom line objectives for fisheries. This is just an example of how we can actually use this flexible framework to simulation test and also test against a range of different performance indicators. So this particular fishery in Torres Strait, the tropical rock lobster fishery, is a very complicated life cycle with larvae that are transported right around a coral sea gyre for about 5 months of the year, and then return into Torres Strait. So we get very variable recruitment in Torres Strait. And climate change is impacting not only that larval circulation, but also the lobsters themselves, for example, the survival. So there's a range of ways in which we need to be thinking about how does climate change impact a stock like this. One of the ways in this example is that we're actually able to estimate in the stock assessment model to what extent does temperature impact the survival of the lobsters. So at very high temperatures, like we're starting to see under climate change, we see an increase in the mortality. So that's a way we can directly actually implement that into our model, and we can then use that sort of model as an operating model in our MSC, or we can use it as a standalone stock assessment. In this particular fishery, rather than using a stock assessment to set the management advice, we use an empirical harvest control rule. So what this is quite a simple rule. I'll show you the details of the rule, but it draws on the available information that we have for the fishery. So we have an annual survey of the incoming recruitment. So we look at the trends in the survey, and we look at trends in the CPUE, as well as what have the recent catches been. And this goes into a formula which sets the RBC, which means that about a week or two after the annual survey is conducted, we're able to come up with a recommended biological catch, or RBC, for that fishery, which is something that's very difficult if you're trying to do a stock assessment in the space of a week or two. So if you need highly adaptive management, this is where a control rule like this that's been pre-tested can be very effective at very rapidly adjusting your management advice, taking into account indicators which you've pre-tested will tell you what's happening in that particular fishery. So how do we check that this rule is robust? There's a number of different types of uncertainty. And again, this is where MSC is a really helpful tool, because you can set up an MSC framework that allows you to test different kinds of uncertainty. So for example, process uncertainty, in addition to the normal sources of process uncertainty, you can bring in climate change scenarios to test how is climate impacting the dynamics of that fishery. Your model uncertainty, you can include a set of models where you have some that are linked to climate and some that aren't, or some that explore hypotheses. And I'll give you an example of that. You can look at different estimation uncertainty and implementation uncertainty. For example, some of the transboundary interactions that William talked about. So once you've established your set of operating models, you can then line up your different candidate models. You can use your models and line up your alternative harvest control rules and see how they perform. So this is where we can have, this is an example of how we actually do this process. So here are 12 alternative harvest control rules. So each of these are like candidates to do the job of telling you how to adjust your management advice. So each candidate says, well, here's how I perform in terms of the risk to the fishery traded against how much catch you get under this particular rule. So you might get a really high catch from one of these rules, but you might find it's too risky because there's too high a risk to the particular fishery, or it might be that it's too variable. And so you cross off some of these and you gradually reduce the scope. And eventually what you want is a small set that you've shown are robust to all the different uncertainties that you've tested across. And then you iterate with your stakeholders to decide which rule to implement. In this case, this final rule was one that used the sources of information I showed you and had different relative weightings for the different pieces of information. And essentially that rule, which was implemented as policy in 2019, looked at the past history of the stock. So there's a lot of variability in it. And then it forecast that you would continue to have a lot of future variability in both your catch and spawning biomass, but it was trying to ensure that the spawning biomass will never drop below some minimum level. And this is where you want to, when you bring in the climate dimension, you want to ensure that given your plausible climate change scenarios, the stock is not dropping below that level. But it's more complicated than that, because we've had a number of changes since we implemented this rule. COVID came and caused a shock. We've had fuel increases, we've had market issues, and climate change has caused some really extreme impacts in a number of our northern systems. And so there's this iterative process where we constantly need to go back and look at that empirical harvest control rule in this case, and do some further testing to make it even more robust, to bring in the new knowledge that we have about how climate change is impacting the stock, but also how are the market factors, for example, influencing the information and the data and the indicators that are part of that harvest strategy process. So we're in the process of testing revisions to this rule, because we know that there are some areas where it's not performed as well as we would have liked it to. That is something that's happening increasingly in fisheries around the world. And often what happens is we do this testing when we have our harvest strategy, but then we have to invoke exceptional circumstances. So exceptional circumstances are when you say, well, something's happened which is outside the bounds of the variability that we tested in our harvest strategy testing. So COVID was a good example of that. We hadn't actually tested the new harvest strategy to be robust to COVID, which had a number of impacts on the fishery. Climate change, we're starting to see new impacts on stocks that we may not have accounted for in our original testing. So every few years, we need to sort of open up the whole thing again, make sure that we account for those new uncertainties in our operating models, look again at which rules perform the best, and consider how to revise those harvest strategies. And in this case, we're looking at how to revise that harvest control rule. A second example comes from our northern prawn fishery. This is the red-legged banana prawn. And this is a really neat example of how we've tried to how to improve the climate robustness of this fishery. So in this case, the process actually started with industry members giving us some information about observations in 2015 that they'd seen unusual tides and so forth. We then followed up and tried to understand what it was they were actually reporting by looking at some satellite images and some other information, and we realized it was to do with low sea level heights during El Nino, which was disrupting the connectivity of these prawns in this fishery. Subsequent to that, we developed a number of models to explore linking this environmental impact onto the prawns, and then we used management strategy evaluation to evaluate how to build robustness to climate change. And the next step was then, in consultation with stakeholders, we reviewed a number of alternative harvest strategies, and a new harvest strategy was implemented in 2021. In that particular case, in the MSC testing, we used a number of different operating models. So some of the models were quite similar to the stock assessment. Some of the stakeholders were a little bit skeptical about the environmental relationships, and we didn't have a huge amount of information to support them. And so what we agreed was to have some models with these linked impacts and others with variants of that or with no impact. So we had a suite of models, and then we tested performance across this range of different operating models. We similarly then tested a number of harvest control rules, where some of the harvest control rules had explicitly in them this environmental factors. So we had, the Southern Oscillation Index was explicitly in some harvest control rules. So you could look at what is the Southern Oscillation Index, and you could then adjust your management advice as part of the rule we tested. That rule actually performed quite well. But in the end, the preferred rule that was chosen in consultation with stakeholders was one that didn't actually even have an environmental relationship in it. It was one that involved permanently closing the first season each year to the fishery. And there were a number of reasons why that actually performed as well as one with the environmental driver. But the interesting thing is that we came up with a rule that industry were much happier with, because logistically it worked better for them. There were a number of other reasons why it worked well for them. And at the same time, the rule actually addressed this main concern, was that we had to consider the impact of the El Niños on the fishery. So you can sort of indirectly address some of these climate change robustness issues with a rule, and in this case, come up with a rule in consultation with your stakeholders, which actually has even more benefits. It turned out that the rule they preferred also performed quite well economically. So it was sort of a win-win in the end. We not only achieved the climate robustness, but we got a rule that industry were much happier with, and that was the final rule that was implemented. So just very briefly, to step back again to the idea of these operating models, which can incorporate in them a range of different climate change and environmental drivers. This is ongoing work that my team are doing, where we sort of increasing the understanding of how these environmental drivers are impacting a number of species in that northern prawn fishery. Excuse me. In this case, using mice models. And this links also to the points that William and Desiree made about needing to have more conservation-focused harvest strategies. So until we have this sort of understanding, which some of our broader ecosystem models can give us, it's difficult to really test these harvest strategies in a holistic way, given that climate is impacting not just the target stocks, but also their habitats and other dependent species in the system. So sort of understanding, for example, at the top here, we've got, rainfall as flow anomalies, how it affects habitats, how it affects your target fishery species, as well as a bycatch and species of conservation concern. That's something we can use as an operating model to then further improve our harvest strategies down the line. So I'll leave it there, but I'm happy to answer any questions. So thanks very much. And just to acknowledge my very many collaborators and my different project teams, but in particular, Laura Blamey, whose work I refer to. Thank you.
Thank you, Eva. That was a very nice way to finish off the presentations in really giving us a good overview of the MSE process. And because this is what a lot of this is about, and then with examples as well to show us how the MSE is being applied in real situations and incorporating those uncertainties through those various alternatives operating models and different approaches to having operating models. I'm sort of used to just using the one type of operating model, which is a kind of a quasi stock assessment model, but it's sort of got me thinking that you can have all kinds of different models in the operating model suite if you want to pull out different performance measures as well. So let's open it up for Q&A of any of the speakers. So raise your hand if you want to ask a question, or type in the chat box. But I might kick off while people are thinking to you, Eva, since you're the last speaker, you get to get my question. And it just sort of come up when you were talking about, the different alternatives to creating operating models and the many options. Like if you ask a biologist or someone to think about the future and the uncertainties, we can come up with lots of different scenarios, and we can provide, good theories and maybe some predictive capacity around these. When we typically go and try and set up these MSE frameworks, we work with stakeholders and we go through the uncertainties and we try to get some sort of agreement on what the suite of OMs look like. And I start to wonder, with the type of work you're doing and bringing in these ecosystem models, and it becomes very overwhelming for stakeholders. And in this situation, is this something that we should just trust the scientists to come up with these OMs and say, well, this is what we really need to be putting in?
Thanks, Paul. It's a great question because I love to say just trust the scientists, but that doesn't work. So my experience is that you do need to get the buy-in of your stakeholders. That's absolutely key. And so what we tend to do is try to have those discussions in a structured sort of way where we make it more hypothesis driven in terms of how we gain, which factors we're going to incorporate. So we encourage a very structured way rather than just sort of throwing in everything. But sometimes if there's quite a strong feeling about a particular hypothesis, we will try to include it if there's enough to support it, or we'll try to show why it doesn't actually work. But I guess the tricky step as a scientist is that working with, and I mean, I call myself a biologist and a modeler, but the more people understand about the system, the more they want to see all that mechanistic information and detail in the models. Whereas we'll often say, well, actually, I can wrap that up in one statistical curve. So it's about just communicating why we do the models sometimes in the way we do, and that what I often say to them is, yes, these are all important, but we're starting with the primary effect. What do we think is the primary driver? And then we see how much of the variation in the system we think that can explain. And then we only add additional complexity if it significantly sort of explains more of what's happening in the system. So I think, yes, it's a good point. You have to be careful not to just throw everything in, but to iterate with stakeholders, but in this constructive way of saying, well, let's start here. What do you think is the primary factor, and just being careful not to make it too overwhelming.
Yeah, and blow out your computation to an impossible degree. Yeah, thanks. That's a good perspective. I'm just looking in the chat box. We have one question in the Q&A box. If people remember, there is a Q&A window there that you can type into. It's from Bruno Minuzzi-Shims. If you're still there, Bruno, your full question is not clear if you would like to ask it over the floor. Yeah, maybe Bruno's gone. I have some questions here that were proposed by the Ocean Foundation, I guess, preempting some of the discussions and things, and some of the things that they might have liked to flush out of the workshop. So I'm going to go to Callie. I'm just interested, given that the challenges that climate change poses, can you elaborate a bit more on these specific adaptations or policy shifts that RFMOs should be considering to address the impacts of climate change? And, perhaps reflecting on some of William's presentation on all these other things and perhaps hidden consequences that we may not have thought of. And one that comes to mind for me that's very real in the global oceans in the Pacific now is marine spatial planning and 30 by 30. We're being asked to explore options for sharing the EZs of countries amongst different uses. And I haven't sort of heard of MSP issues being discussed in any of the RFMOs to date. So yeah, just maybe some reflections on that.
Thank you. I noted that slide with interest as well in Dr. Chung's talk, and I think that in fact does highlight the issues associated with multiple uses of the ocean. So I'll reflect a little bit on a few things in the ongoing evolution of discussions within the RFMOs. And one of the things I wanted to reflect on is, as noted, there's a lot of momentum developing as to how fisheries managers can address climate change risks. And I think we heard throughout the talks a number of issues associated with that, emerging issues, questions as to whether or not the management of the past is appropriate for the management of the future. These are really tough questions, and I think the RFMOs are confronted with whether or not the status quo is enough to anticipate the changes that are coming. Some of the things I've heard, and I'm glad we heard about a few of the other species, because while we tend to be thinking right now as the impacts on tuna, obviously they have prey interactions, and some of those prey are managed by different RFMOs that aren't managing highly migratory species necessarily. So the need to coordinate between the different RFMOs, learn across the RFMOs, share the scientific information. These are kind of all new things for some of these discussions as to how we coordinate globally in a response to this issue. I do think, turning to the final part of your question regarding kind of the spatial management question, as the BBNJ agreement also evolves towards ratification, I think that this is, in fact, presenting a question as to how the RFMOs will engage in that process as other bodies contemplate other uses of the ocean, the potential need for protected areas, and how the bodies with competence over fisheries are part of that discussion. And I think that is all very much still remains to be seen as to how that happens. But I think the conversation has started, and I also look forward to seeing how that develops within the RFMOs. I hope that answers the question, but I'm happy to dive deeper if needed.
Yeah, I think it's another one of those areas that we can be considering, perhaps within the context of management strategy evaluations, alternative management changes coming in on top of what we normally would do with fisheries, is manage effort and catch and these kind of things. So I have a question from Nicola Fernandez in Spanish. Would you like to provide that question over the floor so that translators can translate it, Nicola?
Sí, gracias.
Gracias.
Quiero decir que soy sector pesquero artesanal. Considero que el cambio climático va más deprisa que el conocimiento científico y por tanto no siempre las reglas de gestión o las fórmulas que permiten el establecimiento de reglas de gestión ayuda a poder hacer una buena gestión de los recursos. Casi siempre va la acción de la aplicación de la gestión tardía, va tarde. Y los estudios científicos también van muy tarde. Creo que hay algo importante y es, no sé qué opináis, pero considero que debería de ir más unida la investigación científica con el conocimiento empírico. Con los doctores de la ciencia, como digo yo siempre, con los doctores de la pesca, de la mar, con los profesionales de la mar. Hay una realidad, yo os expongo la que vivo. En el Mediterráneo y en el estrecho de Gibraltar, actualmente han desaparecido muchas especies habituales. Han sido desplazadas, se han desplazado. Otra, no sabemos qué ha pasado con ella. Lo que sí es verdad que hay una abundancia en exceso de atún rojo. Pero claro, en tanto que las reglas se establecen para tan largo plazo, cuando nos damos cuenta, ha desaparecido muchas de las especies y por tanto se ha transformado las posibilidades de pesca del propio sector pesquero. ¿Eso a qué nos lleva? Nos lleva a que mucha parte, gran parte del sector pesquero artesanal que vive en las zonas ribereñas no puede, no tiene capacidad de tener otra forma de vida si no tiene la posibilidad de pescar la única especie que está quedando. Y todo es porque la aplicación de las reglas de gestión de determinadas especies llegan tarde y mal. Pero hay una realidad. No podremos cumplir como pescadores con la misión de soberanía alimentaria y, en segundo lugar, estamos empobreciendo a las comunidades pesqueras locales y nunca se cuenta con nosotros a la hora de determinar pues, las reglas de gestión de los recursos. Gracias.
Thank you. I'm not sure if any of the speakers would like to respond to that. I think the comments were really about how slow things can take, because management might be waiting on science to advise it, and the science takes time, particularly when we're working on these big problems. And there's always these lags and delays, and we see this in these RFMOs where things get put off from year after year. And I think that's one of the key things about this harvest strategy approach. If you can get it going, is it removes a lot of the I guess the paralysis in the management system. So that's a positive thing for the issues you're talking about. But I think also you're also concerned with the I guess the lack of consideration of the smaller scale fisheries. The big tuna RFMOs are focusing on the industrialized fisheries and not bringing in the implications of their management approaches to the smaller scale fisheries. And I guess this is relevant in the Pacific area as well, in terms of the coastal fisheries of the island. So I think Eva and others had, talked about bringing in the social aspects and the social performance indicators, artisanal fishery performance indicators into the process a bit more explicitly. So yeah, I think that's important to consider too. Like you said, that's a good point. Eva, you work on these smaller fisheries in Australia. Do you bring in these other issues, Indigenous fisheries, and into the performance measures that you test?
Yeah, thanks, Paul. It's it's a really hard area, but I feel like we're making a little bit of progress. There's a number of ways you can bring them in. As I said, there is this actually explicitly trying to list them as performance indicators when you're doing your MSC testing. But there's other ways with the reference levels. So in the same way people talk about adjusting reference levels so that you account, for example, for predation needs for forage fish, you can also adjust your reference levels to account for social cultural considerations. So in our Torres Strait fishery, where we work with traditional owners, their preference is to have more conservative reference levels. So in consultation with them, we will choose target reference levels that are more socioculturally acceptable. So that's another way you can actually start bringing these things into it. And that, that has then the add-on benefits, which they recognize, is that it provides a bit more robustness against climate change impacts as well. So yeah, to me, a lot of what we've been trying to achieve in fisheries is actually quite closely linked, the social aspirations, particularly of, small scale fishers, and, looking after cultures and livelihoods of people, as well as looking after the broader ecosystem. When you're trying to do those things well, you often are actually also building robustness to climate change in taking that more holistic look.
Thanks, Eva. And we might come back to this later from the perspective of RFMOs, which are, focusing on the large oceanic stocks. And coastal fisheries tend to have their own processes and they're not really present in the RFMO space. So we might throw it to you, Kelly, in a minute. I want to let Stephen, who's had his hand up for a little while. Stephen Adolf, you have a question?
Yes, thank you very much, Paul. First of all, I want to thank you for all the very interesting presentations. It was really, it put the finger on a lot of the developments which really have to take a lot of time and forces to make some fundamental changes. And that is where my question is to. I'm senior advisor with accountability.fish. We try to improve and change the performances of the RFMOs, especially on their governance. We try to make it more open, more transparent, more accountable, but also in relation to all the biodiversity, climate change, and all other agreements like BBNJ coming to us, to see if we can really fundamentally change not only the structure of the RFMOs, which will be necessary to cope with all these new challenges, but also the content, like for instance, the science that we need. And with that, probably also a lot of the finance, because if you just realize after looking at your presentation what kind of new science will be needed to put in all these models and try to cope with it, that is quite impressive. My question is, and that's actually for all of you, do you have any suggestions? Of course, you are scientists. It's maybe not your first task to comment on governance issues, but do you have any suggestions on how we can speed up this whole process of fundamental change in the RFMOs that will be needed to really cope with all these challenges that come out of climate and biodiversity issues?
Thanks, Stephen. I might throw to Kelly, since this was about RFMO adjustments and changes.
I appreciate that question. I'm fairly new to the RFMO space. I've been doing this for about 3 years, and I will note that's an excellent question with probably an unsatisfying answer at this time. I think we're all confronted with this existential threat represented by climate change. It's moving at a pace faster than our processes. And I think it's introducing a realm of uncertainty in our business as usual approach that has worked in managing stocks sustainably for the period prior to this, and so I share your interest in this topic, but I think when we're talking about adjustments to the fundamental cultural underpinning of organizations, how we do that and how we emphasize the imperative ahead of us will be the challenge ahead. I think we've started the conversation and the momentum, and it's really incumbent on, pardon me, the organizations themselves to embrace this. And I'll come back, and because I think this is a role also for stakeholders to communicate with your managers if this is a priority and something that you want to make sure that the managers are taking into account with respect to how we make decisions. Communicating that up to your decision makers is a way to ensure that it stays front of mind. And Paul, if I might, I wanted to address the stakeholder question that came up from a manager's perspective and the small scale fisheries. I'm happy to hold if there are other questions, and I know we're kind of at time, but wanted to reflect on the question from Mr. Fernandez if there was an opportunity.
Yes, please. Go ahead.
Yeah, I wanted to note, I think it's maybe not obvious when you think about the United States, but we also have a number of small-scale fisheries that we represent in the RFMO context, particularly in the Atlantic Ocean. And with respect to your question, again, I will rely on how imperative it is for the managers representing our stakeholders at these international negotiations to engage, to get that stakeholder input. And that extends beyond commercial industrial scale interests. And so I would put the onus of responsibility for that on the managers to make sure that they're reaching out and engaging. And part of that stakeholder engagement through the management strategy evaluation process is the key to the success of the ultimate decisions that are made regarding the final management procedures that are determined. So thanks for letting me go back and answer that question, because I thought it was a really important point that Mr. Fernandez raised.
Yeah, thank you, Kelly. And it's come up in the WCPFC when we're looking at, say, skipjack, where you have a fishery off Japan, which is a historic cultural fishery there, pole and line fishing, and it's come back to a scientific challenge in that, you know, can you have performance indicators specific to our zone, to our EEZ, to our region, that then we can then, you know, because that's important to us, but we're limited by the capacity of our models to predict accurately at those scales, to be able to provide sort of local advice on the performance of management procedures for within EZs or you know, in those coastal fisheries. So we probably need to have other performance indicators or monitoring that is built into these, so that we can track the performance of those smaller scale fisheries that catch the same stocks. Did anyone else want to have any input on that question? Just looking for any other questions in the boxes. Desiree. I think you're muted, Desiree.
Thanks. It's a bit noisy here, but I just wanted to answer also, talk about what Stephen raised. So what are the initial steps that we can take at the RFMO level? So in terms, and I'm speaking from more of a scientific perspective, but I think just increasing the level of climate literacy, you know, across the RFMOs will be important. And both at the management level, but also within scientific groups that are providing the science to the RFMOs would be important, and maybe just expanding a little bit the scientists that partake in the scientific meetings to include maybe more climate scientists and ecologists as well. And then, yeah, just stressing the importance of listening to the stakeholders and of continued monitoring to detect those changing that Nicholas was also talking about.
Yeah, Desiree, if I could just, your last slide with those, I think there was about 45 faces on that slide of people from all different disciplines, you know, that you're working alongside of. You have economists and social scientists and oceanographers. How does all that work? How do you communicate and you know, how does that all come together?
Yeah, I love to say, so this project has been going on for many years and it's not always straightforward. So, but it takes that iterative interactions across discipline to eventually build that understanding. And so often we have, you know, economists with their specific impact model that relates to you know, building a bioeconomic model, for instance. And so they have to understand from the oceanographers how that input can be implemented in their model and how that might affect then the fisheries. So it just, I think communication is key. It takes a lot of interaction across discipline and also having people that can speak across discipline too is important. But I think just starting to invite members from other discipline into, for instance, in ISD, which I'm familiar with the working group that we are working with, they're often, they include some fish biologists and fishery scientists, but not oceanographers or ecologists, which we could invite as speakers, for instance, just to increase the level of climate literacy and understanding into how, what are the uncertainty too. I think David D spoke about that in the chat, but also as fishery scientists being aware of the uncertainties associated with projections and predictions when we integrate those into our fisheries models.
Yeah, I've just had recent discussions with, to's and froms, as I mentioned to you in email, between Patrick and Ina, who work on CIPIDM, and our stock assessment modelers, and realizing that, that even with, we've worked together for many years, we still don't really fully understand how we each do things, the finer details, and that's important that we get those understandings, so that we can explore how we can integrate these other models in and commonalities in them to these sort of MSE challenges. I think we're a little bit over, but I was happy to go for another 10 minutes or so to tease out some of these discussions.
Sorry.
Want to keep.
Oh,
yeah, William.
Yes, I couldn't find a raise hand button. So if you don't mind,
please.
Yeah, just to follow up on that, I think on the importance of having the interdisciplinary participation, stakeholder participation. And I think and we talk a lot about modeling, very technical kind of aspect of the management of fisheries, which is really important. I think there's also the another dimensions, the tools that are really useful in this context, that provide that more bigger context to help with informing the modeling part, is kind of the scenario development component. There's lots of advancements in actually using a scenario as a tools to help people think about the future, and that's really useful in the climate change context because it involves so much other aspect, cost-cutting issues that are beyond traditional fisheries management, that focusing on harvest strategies and management of specific fish stocks, the economics of fishing, but then it relates to the border changes that some of it has been talked about. So I think it is very useful to use these scenario tools to really make consensus or develop visions about what the futures among different stakeholders would want to achieve, like in terms of biodiversity, in terms of economics, fisheries, social, food security, and given the potential kind of expectations or potential shocks or unexpectations that may happen in the future, and that can then provide that more overarching inputs to inform some of the the management strategy evaluations exercise, and I think that could be quite a useful thing. So then social scientists and scenario, like there are specialists who are working on those scenario exercise and really innovative tools and ideas, and fun exercise too. A lot of it involve a workshop and things like that, and innovative presentations of future scenarios. I think that could bring in quite useful discussions to the RFMO, the stakeholders, and discuss about how to prepare for climate change in the fisheries management. Thank you.
Yeah, and as you were speaking, I was sort of thinking about setting objectives at the start of these processes, and we don't often confront the stakeholders with, well, in the future it may be that this is what you're going to be having to choose between, or make trade-offs with. Those trade-offs may not be clear right now, but in the future they will come into play. And so when we're developing objectives and working with stakeholders on what do you want to get out of your management procedure, we probably need to be thinking about those objectives that are, or those trade-offs that are into the future, are not too far away, and make sure that we also understand how stakeholders would would like the outcomes of those trade-offs to go in terms of, you know, their interests. Yeah, it's very interesting. Any of the other speakers like to bring up anything else? I guess we could go on, but I guess we need to wind up. People have got things to do and places to go, and I think the whole sort of climate literacy, maybe Shana, is something that your organisation could become interested in. You know, this is a big project on harvest strategies. There's obviously a need now to do a sort of climate literacy, climate awareness program now in relation to fisheries. And SBC had their first climate awareness workshop in Auckland this year, which was a really big success, where we brought stakeholders from around the Pacific, and we got a range of speakers to come and talk about climate change, climate language, and just try to start to build that literacy into the stakeholders. And I think that's going to happen again. They definitely want more of this stuff. So maybe Shana, we can think about something for the future after this MSc project is passed, or maybe. I'm just looking for any more questions. I don't think there is. So I think we might wrap it up for tonight and today, or whatever time of the hour it is, wherever you are. I'd once again just like to thank our speakers, and particularly the three that are on leave. Thank you so much for joining us. But yeah, definitely thank you to all our speakers. I think we've had a great session and really insightful presentations, and some things to go away and think about, I'm sure. So thank you all for your time, and thank you everyone for joining us online all around the world. I think we've had another great webinar, and don't forget there's 11 more of these. So please keep your eye on the Ocean Foundation harveststrategies.org website. There's plenty more to talk about. So thank you all, and enjoy the rest of your evening or day.
Thank you, Paul.
Thank you, Patrick.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye.
Thank